Hi, today is December 26, 2024. In this video, we will talk about Python functions. To make our Python code more readable and reusable, we can create functions. In this video, we will talk about two ways of creating functions. First, the def statement. We can use it to create any type of functions. And secondly, the lambda statement. This one is useful for creating short, anonymous functions. Before we talk about defining our own functions, let's see how to use functions in general. So functions are groups of code that have a name and can be called using parentheses. We have seen many functions so far already. For example, the print function. Print is the function name, and good morning in this example is the argument. In addition to arguments, there are keywords arguments that are specified by names. So let's take a look at one example. Still, the print function. We can print 1, 2, 3, and then add a keyword argument, SEP, separator. Separator equals hyphen. Let's run this. We use the hyphen to connect the three numbers. Another example is this one. We have seen this before, the AND argument. This is also a keyword argument. By using this argument, we can put the numbers in one line. So when non-keyword arguments are used together with keyword arguments, the keyword arguments must come at the end. Just pay attention to this. So in these two examples, it's very obvious. So these three are non-keyword arguments, and the last one is a keyword argument. We have to put the keyword argument at the end of the argument list. Then let's talk about how to define functions. First, defining functions using the def function. We also have seen examples previously. So let's create a function to list n Fibonacci numbers starting from 0 and 1. Whenever we create a function, we start with the def keyword and then give a name to the function. We can just call it Fibonacci. And then parentheses. In the parentheses, list all the arguments that are needed for your function. In this function, we only need one argument, which is the number of Fibonacci numbers. L is an empty list. Then we specify the starting values of the Fibonacci sequence, 0 and 1. And then we use a while loop to repeatedly fill the list. The condition is the length of L is less than n. Okay, so let's see how it works. Then suppose we want to list 12 Fibonacci numbers starting from 0 and 1. We can call the function immediately. You see, this is the result. We only need one argument, which is the length of the sequence, starting from 0 and 1. And functions can return multiple values at the same time. We just need to put them in a tuple format. Namely, we need to separate them by commas. For example, suppose we want to return the real part, the imaginary part, and the conjugate of a complex number. We can create a function like this. So the function name is called real, imagine, and conjugate. And there is only one argument, which is the value. And then we return three things: the real part, the imaginary part, and the conjugate. So apparently for complex numbers, these three are valid methods associated with complex numbers. So real will call the real part, and imag will extract the imaginary part, and conjugate, this method will calculate the conjugate of a complex number. So let's define this, and then let's apply the function to a complex number 3 plus 4j and see what happens. So 3 is the real part, 4 is the imaginary part, and 3 minus 4j is the conjugate of this complex number. So just for your knowledge, in Python, complex numbers are represented as x plus yj. So it must be in this format, something plus something j, not I. Okay, so x is the real part, y is the imaginary part, and j represents the imaginary unit, which is square root of -1. Next example. And suppose we want to calculate the length and the mean of a vector of values. We can do the following. First, import the NumPy package and then define the function. We give it a name, and there is only one argument. We call it vect, which means vector, and we will return the length of it and the mean of the vector. Notice that we called the NumPy's mean function. Right? And then if we apply the function to a list of numbers, we get the correct result. The length is 5, right? And the mean of this vector is 3. So the point is, it's possible to return multiple values. You just need to separate them by commas. Sometimes when we define functions, there are certain argument values that we want the function to use most of the time, but we also want to give some flexibility to the users of the function. In this case, we can use default values for arguments. For example, in the Fibonacci function we created before, instead of starting from 0 and 1 always, we can let the user define the first two values in the sequence. In this case, in addition to the number of numbers in the sequence, we can add two more arguments, A and B. Okay. And so these two are the starting values of the sequence. And we also give them default values, 0 and 1, which means if the user does not specify the starting values, then A and B will be assumed to be 0 and 1. But if they want the sequence to start with different values, they can do so easily. So let's see how it works. If you don't specify the values of A and B, the result of the function will be identical as before. So if we run it, so the function can still be called in this way because A and B have default values. You don't have to specify them. However, apparently n has no default values, so you have to specify the number of numbers in the sequence. If we want to have a sequence starting from 1 and 3 instead, we can call the function in this way. A is 1, B is 3, so still 12 numbers. So let's run this. Then we get a Fibonacci sequence starting from 1 and 3. And if we specify the arguments by names, then we can change the orders of them. So for example, if we use argument names for all of the arguments, then we can put them in different orders. Originally, we have N, A, and B. But if we specify them using their names, we can change their ordering. Lastly, let's see how to define anonymous functions using lambda. So the lambda statement is a way to define short one-off functions. It looks something like this. Add equals lambda xy colon x plus y, and then we can call the function. Okay. See how it works. So 10 plus -10, of course, is equal to 0. So this is roughly speaking equivalent to the function defined using the add function like this. So the name of the function is add, and we can just define a simple function like this. Is equivalent to this. That's all for this video, and this is the last video in the Python for beginners in data science. And in the near future, I will create a series of videos about data visualization using Python packages. Alright, thanks for watching. See you next time.